Hello and welcome back to the series on OCR and Python. In the last video, we looked at a very basic way to take this image and really kind of use PyTesseract to take it from an image into a string, and we saw the OCR output from that. However, I raised a few alarms about doing that, mainly because we're dealing with 3 different columns of data, and it is always good practice when you're OCRing something like this, like a typical index, to separate it out into individual images. And that's going to be what we do in this video. Our goal is really in this video to have a new output. We're looking to have 3 columns saved as individual images. And then what we're going to do in the next video is we're going to start doing some post-OCR processing to that to generate a named entity list from these 3 separate images. So let's go ahead and jump right in. What we're going to do first is we're going to be importing what we need to use for this video. So we're going to be importing PyTesseract, just like we saw in the last video, but unlike the last video, we're not going to be using Pillow. We're going to use that more advanced library called OpenCV, and we're going to be specifically importing CV2. Now, I've talked about OpenCV in the past videos. It's a computer vision library for Python. It's more robust than Pillow. I've got videos on that already. So what I want to kind of do right now is simply explain why we're using OpenCV. OpenCV is going to allow us to do a few kind of pre-processing things to the image, specifically blur it and then identify structure. This is kind of the typical way in which you OCR something that has different areas of text. In this case, 3 columns of text that we want to OCR. Our goal is to take the original image, do some pre-processing methods, specifically blurring everything so that nothing's legible as text, but columns are able to be identified by them. That's going to make a lot more sense as we kind of go forward. So let's go ahead and start doing that right now. So what we want to do first is we want to create an object called image. This is going to be our actual CV2 image. I'm going to zoom in a little bit so you can see a bit better. So this is going to be cv2.imread, and this is going to be specifically the file in which it's found. So this is going to be data \index_o2.jpg. So now that we've got that image kind of loaded in memory, we can start doing some pre-processing methods to it. And I'm going to kind of show you what these pre-processing methods look like at each different stage of this process. So let's first go ahead and create a gray image. Now, I've spoken a lot about kind of pre-processing methods in the past video, but now we're going to be doing them to achieve a specific output. So the first thing we need to do is we need to gray this image out. So let's go ahead and do that by using cv2.color BGR to gray. And if you want to know what each of these things are, please do look at my previous video on pre-processing images for PyTesseract. So now that we've got that gray image, let's go ahead and kind of see what that image looks like. And we can do that by doing cv2.imWrite, and we're going to write in temp, and we're going to say index gray let's do .png, and we're going to save that gray file. Let's go ahead and see what that gray file looks like now. So it's index_gray, and it doesn't look a lot different. It looks relatively the same because we already had a fairly grayed out image. Now that we've got that though, let's go ahead and do another pre-processing technique on this. This is going to be our blur technique. So let's create an object called blur, and we haven't seen this yet in this series. We're going to do cv2.Gaussian, spelled with 2 S's, blur, capital G and capital B. And we're going to have a few arguments here. The first thing is going to be the object that we want to perform the Gaussian blur to, which is going to be that gray image. The next thing that we want to do is we want to specify the size of the blurring. We're going to stick with 7x7 right now, but you can play around with these. And then finally, we're going to just pass in 0. And we're going to go ahead and execute that. And we see that everything works. And copying and pasting is never a good idea in code, but don't worry about it. I know what I'm doing here. We're going to call this one index_blur. Let's go ahead and save that. And let's see what an index_blur looks like. And I think in JupyterLab, I have to kind of go out each time to do this. So let's see what that looks like. So this is what a blur looks like. So we're getting a blurred effect on this page, and it's making the text a little less legible. But that's not really our concern at this stage. Our concern at this stage is identifying not text, rather structure. And that's going to be what this blur method allows for us to do. So let's go back in to our main Jupyter notebook here, and let's start doing our next thing that we need to do to this image, which is create essentially a threshold image. So we're going to say thresh is going to be equal to cv2 dot threshold, there we go. And we're going to specifically pass in that blurred object, and now we're going to pass in 0255, and this is going to allow us to actually pass in thresh binary underscore inv. We're going to say plus cv2 dot thresh, and we're going to use the Otsu method here. And again, I've covered all this in my past video on thresholds. Let's make sure that worked correctly, and it looks like we've got an error. Thresh, looks like I misspelled thresh here. There we go. Now it should work just fine. Now let's go ahead and see what that looks like. So we're going to say this, and we're going to call this thresh. Oop, sorry about that. Thresh, and we're going to pass in that image there. Let's go ahead and save that, go back into our temp folder and see what it looks like. Now we've got a threshed image. Now what we're seeing here is that blur technique really coming out. We can start to see that there is a clear lack of discernible text. We can't really read this that well. We might be able to zoom in and pick out some things, but we're really blurring a lot of the lines here. And that's our goal, is to get these texts into more or less columns, not just text. So we have to do another pre-processing technique on this, and that's going to be the creation of individual kind of kernels and dilation. Now, I've talked about kernels and dilation in a past video as well, so let's go ahead and just jump right in. So we're going to say kernel is equal to cv2 getStructuring element here. A capital S and a capital E, very important. It's easy to make those mistakes here. cv2.morph underscore rect, and then we're going to pass in another argument, and this is going to be the kind of the kernel size. Essentially, think of this as a way to kind of blur things vertically and horizontally. You can play around with these and you'll get a better sense of what this kind of does. So let's go ahead and do that right now, and like before, we're going to do this. We're going to say kernel there and kernel there. And let's go ahead and write that so you can kind of see what that looks like now. Go back into our temp folder, and we have kernel. We're not seeing really anything here. That's perfectly fine. Don't worry about that right now. And so what we're going to do now is we're going to go back to our Jupyter notebook, and we're going to now dilate our entire thing, our entire image. So let's do dilate is equal to cv2.dilate, and you're going to see the magic happen with this right now. We're going to pass in a few different arguments here. We're going to pass in our thresh image, our kernel, and then what we're going to do is we're going to pass in our iterations here. And that's going to be equal to 1. Now, iterations is going to be how many times that this kernel gets kind of run over that threshold image. Again, you weren't able to see the kernel because it wasn't there. And we're going to go ahead and run that cell. And like last time, we're going to copy this down so you can kind of see what's happening at each stage. We're going to call this dilate. And this is going to be where you start to see what's really important here. And let's go ahead and run that. We're going to go back into our temp folder and pull up dilate. Now you're starting to see the magic happen. This is how we're able to identify structure in a text. What we're essentially doing is blurring kind of all the lines of the text to get these columns kind of extracted from them. And it's going to be that structure that allows for us to now start creating what are called bounding boxes or contours around these columns so that we can start interacting with them as individual components. So let's go ahead and start doing that right now. Now that we have that dilated image, we're going to create the contours. Now, the typical way in which you do this in Python is with CNTS, which stands for contours. And you're going to make that equal to cv2.findContours, contours with a capital C, contours. I always have to spell that correctly. There we go. We're going to pass in that dilated image, and we're going to do cv2.retr external, and then we're going to do cv2.chainApprox simple. Now, I don't want to take credit for someone else's work. I've got this a long time ago from several different sources, mainly on Stack Overflow, and Medium. I apologize if this is your code and I'm using it. I assure you, if you let me know, I'll give you proper attribution. Like I said, I found it many years ago and I just kind of use it in a bunch of different projects. Now that we've got these contours made, we need to do a few things here. The first thing we need to do is we need to say CNT is equal to CNTS 0 if the length of the CNTS equals 2, else CNTS 1. That's going to allow us to actually grab the right contours that we want to work with. And the next thing that we need to do, and I'll explain this in a lot more detail in a later video possibly, we need to sort out these images. Now, one of the things that contours will oftentimes do is you'll have contours that are not organized in a systematic way. They're not organized top to bottom, they're not organized left to right, and you have to actually organize them. So a great way to do this is using lambda. So we're going to, basically, lambda allows for you to pass multiple parameters to a single function. And so we're going to run sorted, and we're going to make that key is equal to lambda x colon cv2 dot bounding rect x and 0. Now, I'm not going to really explain in detail what's happening here. Essentially, what this is allowing us to do is to organize everything in these contours from left to right. And if we execute that, we've now got organized contours. However, we've got a major problem right now. These contours are many, which I'm going to demonstrate to you in just a second. One of the things that we are going to do moving forward is working with OpenCV to eliminate contours that are too small. So let's go ahead and see what these contours look like by marking them on the original image. So we're going to say for C in CNTS, so that's going to iterate over each of these contours, which are a bounding box that contain a few different pieces of information. They contain the x coordinate, the y coordinate, the width, and the height of the box. And you're going to be able to see what these look like in just a second. So we're going to say CV2, make that equal to CV2 dot bounding rect with a capital C, and we're going to pass in the contour there. So that's going to allow us to actually have each of these individual items. Now, with that information, we can now do CV2 dot rectangle, and we can draw a rectangle onto the original image that will be these bounding boxes. And you're going to see what that looks like in just a second. So the first argument here is the image that you want to write these bounding boxes onto or draw the rectangle for. The next thing you need to do is you need to specify how you want that bounding box to be drawn. So we're going to pass in the x and the y coordinates of our contours of our bounding box. And then we're going to pass in the full dimensions here by allowing us to go x plus w, which is going to be the x-axis, plus the width, which is going to specify essentially one parameter, and then the y-axis plus the height, which is going to specify the length of the bounding box beginning at the y position and stretching the height. Essentially what this tells Python and OpenCV is where to draw the actual bounding box. And the next thing we need to specify is the color. A common color people typically use for this is going to be a green. It's kind of an industry standard if you're only working with one color. Sometimes you'll see red. So let's go ahead and do that. And then after we iterate all of that, what we're going to do is we're going to once again save our original image now. And we're going to call this bbox. And what we're going to have is an image that's got a whole bunch of bounding boxes drawn all around it. Where is it? It is right here. If I zoom out, you'll see that what it's been able to do right now, it's been able to identify structure. It's found certain places where contours were identifiable. So it looked at this dilation and it said that, okay, this is a contour, this is a contour, this is a contour, and it's just drawing all these bounding boxes where it's found contours. Now, if you notice, we've got a lot of overlapping contours. We have a lot of messy stuff here that we don't want to see. So mainly what we don't want to see is we don't want any of this stuff up at the top. We don't want any of these small bounding boxes, because if we try to OCR all of this, we're going to get like a whole bunch of essentially just non-legible stuff or stuff that's in wrong order. We want to just be able to grab just these 3 columns. And you notice we've got the 3 columns drawn here. So how do you do that? How do you just get those 3 columns? Well, fortunately, there's a nice little trick that we can do. So one of the things that we can do is we can set up a conditional statement. And what we can say is if the height of the item is greater than 200, so we're looking for something that's relatively tall, and I apologize there. and the width of the item is, let's just say, greater than 20 for right now, then under these conditions, if the bounding box is at least 20 pixels high and 20 pixels wide, then draw the bounding box. And when we rerun this, let me go ahead and I have to reopen up the bounding box image. We'll find that it looks like I didn't close the right one. Okay, I had something stuck in memory, and so it was causing some kinds of problems. But if we execute this code now, we rerun all of those kernels, we now see that we've got this new result. We've got just the bounding boxes of these individual images. Now, what can I do with that? Well, what I can do with that is I can create a simple loop now at this point. I can create what we call an ROI with that information. So I can make ROI equal to, we can make that equal to and the original image, and we can make that equal to kind of the parameters of that bounding box. So we can say ROI is equal to image y plus, I always forget how to do this, y colon y plus h. And I always have to have a cheat sheet when I'm doing this because I can never remember exactly how to structure the ROIs. And we're going to do x is with a colon x plus h. And then what we can actually do is we can save that ROI as an individual file. And I'm not going to try to save each of these right now. I'm just going to demonstrate my point about how we can extract that. And one of the things I like to always do is we can create a base image which is equal to image.copy. And we can rerun all of these cells. And what we're going to find is that we can actually save the original an ROI, which is an individual capturing of one of those bounding boxes. And I believe I have it saved right here. And what we have here is the last column in the list. And we have essentially now been able to demonstrate how we can take this original image and extract these bounding boxes. And here's the most important part. Notice that the original OCR that we were getting in the last video, let's go back to that for just a second, had a couple bad outputs. I didn't specify this enough. It's got these lines here. What's happening is it's catching these lines right here, and it's trying to OCR these lines, even though we know they are just a delineator for different columns. One of the things you're able to see right now from this ROI is that we don't have those column markers there, which means we're going to have a much better and a much easier time of OCRing this. Now, this is going to be where this video ends. In the next video, I'm going to pick up right here where I left off. We are going to take these individual ROIs and OCR them, but we're going to do a couple things in that process. We're going to specifically modify the output so that we can get a structured list of entities from that index. That's going to be where we end now. I want to take a moment and say thank you to all of my Patreon supporters. As always, I try to keep all this content free for the general public so that everyone has access to this information. If you enjoy this channel and get a lot out of it, please do consider supporting it via Patreon. Every little bit helps a lot to keep this channel alive. And if you've enjoyed this video, please like and subscribe down below. Thank you.